right, here is the key to the targets 4 through 6 practice homework test. For the first 3 on target 4, you can use the shortcut where the leading coefficient is 1. So all of them have a leading coefficient of 1, which means they all are going to factor with an x and an x to start with, since these are all trinomials. And then to fill in the other blank, you just have to find the 2 numbers that multiply to 5 and add to 6. So that would be 5 and 1. In this case, number 2, multiply to 63 and add to negative 16. And if it helps, make yourself a little table of all the factors of 63. And you'll stumble across 9 and 7. And if you make them both negative, they will still multiply to positive 63 and add to negative 16. 2 numbers that multiply to 12 and add to negative 7 would be negative 4 and negative 3. For number 4, this one, remember the first thing you should always check for is can you factor a GCF out of those 3, but you cannot. And it doesn't start or end with a perfect square, so you can't use that shortcut. So then we have to rely on the box method. So what we're going to do is following these steps. Step 1 is we're going to fill in these 2 corners with those numbers. In step 2, we have to answer what I call the magic question, which is find 2 things that multiply to this product and add to that middle term. So the product there is 12 times negative 15 is negative 180. So the 2 numbers I need to come up with multiply to negative 180 and add to negative 11. And again, if you're struggling, just go methodically. 1 and 180, 2 and 90, 3 and 60, and just keep going. And what you can do is you can just divide. So 180 divided 3 is 60. If I'm thinking ahead here a little bit, I'm thinking 9 and 20 have a difference of 11. Because 180 divided 9 is 20. So if I make the 20 negative, they will multiply to negative 180 and add to negative 11. Oops, that one's going to be positive. This one's going to be negative. So technically they multiply to negative 180x squared and add to negative 11x. So that's why I put the x's in there. And then step 3 is to factor out the greatest common factor from each row. So I'm looking at this row. 12x squared and negative 20 have a common factor of 4x. 11x and negative 15 have only a common factor of 1. And if I factor up here, made a mistake here. So actually, this is a mistake. This should be a 9x. I'm not sure where I got the 11. The 2 numbers I put in there have to add to 9x, add to negative 11x, so 9 and negative 20. So now for step 3, I'm going to factor out the GCF from each row. So we have a 4x and a 3. And then going up top, we have a 3x and a negative 5. And you can check by multiplying, so our answer is 4x plus 3 times 3x minus 5. So in step 2, the two numbers that multiply to negative 11x and add to negative 180x squared, those are the two numbers that go in these two spots. For numbers 5 and 6, you can use these perfect square shortcuts because it starts with a perfect square and ends with a perfect square. And if you multiply those together, you get 21p, and you double it, you do get the 42p in the middle. So when that happens, your two factors are just going to start and end with those square roots. And then you look at the middle term, and since it's a positive 20 or 42p, I put these as both plus. So I'd get a 21p plus a 21p for my outer and inner terms. You could use the box method for these type as well, but it's much quicker if you use a shortcut. So again, this one starts and ends with a perfect square. The square root of 16x squared is 4x. The square root of 25 is 5. But in this case, there's no middle term. You could think of this as plus 0x. So I'm going to make 1 plus and 1 minus, so I'll have a 20x and a negative 20x. Now for numbers 7 and 8, remember the biggest rule is to always remember to factor out any GCFs first. So I can factor out a 3 from each of these. And we're just going to try to rewrite this equation in factored form. Once I factor that 3 out, then what's left I can factor since the leading coefficient is 1. So I can put an x and an x there and find two numbers that multiply to 25 and add to 10, which would be 5 and 5. You could also use the perfect square shortcut for what was left, because the square root of x squared is x, and the square root of 25 is 5. Another way to write this is 3 times x plus 5, the quantity squared. So I'm going to do the same thing for this one. So I might check for the greatest common factor. I know 2 is, and maybe find a bigger one. Wondered if 4 is a factor of 144. And that might even, I think that'll be it, because if I divide everything by 4, 100 divided by 4 is 25. 240 divided by 4 is 60, and 144 divided by 4 is 36. So I factored that 4 out, and now I can see that I have, it starts with a perfect square. Square root of 25 is 5. It ends with a perfect square. Square root of 36 is 6. And if I make these plus and plus, my outer and inner will be 30g and 30g, which combine to the 60g. There's my answer. So that's target 4, all of our factoring methods. Leading coefficient of 1, box method, perfect squares. The box method would work for all of them, but it will take much longer if you use the box method for all of them. Moving on to target 5. This target is all about finding the vertex, and there are 3 different forms for a quadratic equation. So this first problem is in vertex form, which I've highlighted over here. So to find the vertex, you just kind of verify that it's in that form. This is the A, this is the H, this is the K. So the vertex is the point 7, 5. It's as easy as that. The x-coordinate is always going to be the opposite of this number. And the y-coordinate of the vertex is going to be the same as this number. Now this equation is in standard form. So to find the vertex, we're going to use negative b over 2a. And that's something you're going to want to study and remember for the test. So in this case, a is negative 1, b is negative 1, and c is negative 2. So my axis of symmetry will be negative b over 2a, becomes 1 over negative 2, or negative 1/2. So that is going to be the x-coordinate of my vertex. And then what I can do is I can plug that in my calculator. So I'm going to take negative 1/2. Make sure you put parentheses around the x squared, minus negative 1/2 minus 2. So negative 1.75 is negative 1 3/4, which is negative 7/4. So all I did was plug in the negative 1/2 for these two values and calculated it. So another way to say that is g of negative 1 is negative 7/4. When you put negative 1 in, you get negative 7/4 out, or negative 1.75. The third form here is intercept form. So in intercept form, the values that make this 0, in this case 6 and negative 2, they will make the whole function 0. So they are called the zeros of the function, or the roots. And they translate to our x-intercepts. So the x-intercepts will be 2 points, the point 6, 0 and the point negative 2, 0. If you plug those values into the equation for the x, the function's value will equal 0. So that corresponds to those points on the graph, which are the x-intercepts. From that, if you think kind of graphically about what's happening here, so we have an x-intercept at 6 and another at negative 2. So the vertex is going to be right in the middle of those. They are 8 units apart. So if I go right in the middle, it should be at 4 units either way, which is looks like an x-coordinate of 2. That's going to be my axis of symmetry. You can get that by averaging those two values. So you get 4 divided by 2, which is 2. And that's the x-coordinate of your vertex. And then you just plug that in to your equation. You could use your calculator for this if you'd like. So you get negative 2 times negative 4 times positive 4. So that equals 32. So that would be the point 232 would be the vertex. And then the parabola would open down and intercept the x-axis at those two spots. And you can see how the vertex is right in the middle of negative 2 and 6. So here's the vertex, here's your x-intercepts. Number 4, it says write the equation for a parabola that has the vertex, negative 5, 8, so that's going to be your hk, and passes through this point. This is an xy point. So what I'm going to do is I'm going to substitute as much of that into the problem. So they gave me a y coordinate, so that goes in for y. They did not give me an a value, that's what I have to find here. They gave me an x value of negative 37. They gave me an h of negative 5, and they gave me a k of 8. So I plugged in a value for x and y, h and k that they gave me. And now I can solve this for a. So it would be negative 37 plus a positive 5 plus 8. And I'm just going to solve this for a. So I'm going to get the a alone by subtracting 8. And then dividing by negative 32, because that's being multiplied. And a negative divided negative is a positive. So there's your a value. So now I can write the equation. It's a times x minus h. So minus negative 5 becomes plus 5. The quantity squared plus k. For number 5, we have an equation in standard form. The 74 is the initial height. That's the y-intercept, by the way. So at 0 seconds, the rocket is 70 feet off the ground. This 106 is the initial velocity, and the negative 16 is half of acceleration due to gravity. So to find the maximum height of the rocket, if you think about what's happening, here's your cliff, or let's say this is our time, so t seconds. It starts at 74, it's going to go up, it's going to come down and hit the ground eventually. We're looking for the maximum height, which is the vertex. So it's just an application of that. So we need to find negative b over 2a. So that would end up being 106 over 32, because 2 times 16 is 32, and they're both negative, so the negatives cancel. So it will happen, that's the time, 3.3125 seconds. That's our x-coordinate. The y-coordinate then is the maximum height. So what I need to do is I need to take and plug that into my equation. So one way I can do that is just take negative 16 times that last answer squared plus 106 times that last answer plus 74. And this will be the y-coordinate of the vertex. So it would be 249, we'll just say 0.6. 249.6 feet. So that's our max height. This is the number of seconds after launch that it takes to reach that maximum height. And number 6 is completing the square from standard form to identify the vertex. So the steps here to complete the square is we're first going to factor out the 2 from the terms with the variable. So I factored out a 2 from each of these. You'll notice I also left a blank. That blank there is to complete the square. I'm going to put another blank after the 42 to balance what I do to complete the square. So basically what we're doing is we're trying to change this to x plus something squared, because that would be part of the vertex form, which means it's a square. So I have an x squared, and I have 10x to work with in this problem. So I'm going to split that 10x in half to make it a square. So this would be a 5 and a 5. But that's not a complete square. So to complete the square, 5 times 5 would make this 25. I need this 25 in here to complete the square. And that will make this a perfect x plus 5 times x plus 5 squared, or x plus 5, the quantity squared. But that 25 was not in the original problem, so I'm going to subtract the 25 out here to balance it. And then I remember that this 2 also gets multiplied by everything. So I'm going to have to subtract that 25 twice. So kind of getting this all back together then. It would be y equals 2 times the quantity x plus 5, the quantity squared, plus 48 minus 50, which is a negative 2. So now that it's in this form, I can identify the vertex. The opposite of this, that's the h, same as that. So it would be negative 5, negative 2. So target 5 is all about identifying the vertex from our three forms. Vertex form, standard form, intercept form. And if you have a good understanding of target 5, that will really help you with target 6, which is on graphing quadratic equations in different forms. So this one is in vertex form. It says to graph it and label at least 3 points precisely, including the vertex. So in this problem, I can identify my vertex as HK. It's actually the same vertex as the last one. Opposite of this, same as that. So -5, -2. There's a vertex. Now to get some other points, what you really need to do is just make a table. And that the interesting part about the table is going to be the points that surround that. And maybe, like a y-intercept might be an easy one, which would be a 0 in there. But basically, you just need to find the points that satisfy that. So on your calculator, remember you have the table function. You can push table, and you can type in the equation using the x variable key. And then when you click enter on that, it's going to ask you where you want the table to start. So you should start somewhere around the vertex like I did. So I'm going to choose -7, and my change in table, I'm going to make 1. So then when you click OK, I'm going to make this auto. Otherwise, if it's asked, I can actually type those in, but I'm going to use this. So if it were asked, I could type in -7 for the x, and it would do that. And then I could type any number I wanted for x. So I'm getting some values here when x is -7. If I were to put -7 into that equation, I would get -14. If I were to put -6 in, I'll get -5. And we could verify that. -6 plus 5, the quantity squared, times -3 minus 2. So that would be -1 squared is 1. Times -3 is -3. Minus 2 does give us -5. But the calculator makes that a whole lot easier. Now I didn't need the table to get these because they surround the vertex, so there's going to be this symmetry. And with this scale, the only points I can actually fit on my graph are these. So I have the point -6, -5, and then -4, -5. So now I'm going to do my best to just show where the graph goes, because the next point over, I'm going to be off the chart, kind of way down here. So when you draw your graph, and you connect these with a curve, your curve should not go out like this, because that would be incorrect. Okay, so maybe try to put a point beyond what's on the grid, so you can at least have an accurate graph. And don't forget to put arrows on. There's another question here about converting to standard form. So remember, if you want to convert this equation to standard form, you're really just multiplying out the x plus 5 times x plus 5. Because we're thinking of x plus 5 squared as x plus 5 times itself. So we'd have our -3 right here. X plus 5, the quantity squared, becomes x squared plus 10x plus 25. And then we have our -2. So a little more space there. So this part right here is from this, which is just multiplying that out. Then I would distribute my 3 to everything in the parentheses only. And lastly, combine any like terms. So I can do a lot of the same things for number 2. I could use the table function to help me graph this. But this one is in standard form, so I'm just going to find the vertex to help me with that. The x-coordinate or axis of symmetry would be negative b over 2a, which would be positive 1. So I know that I need to look at that point, that vertex point around 1. And if I put 1 in here, I can see that I'll get negative 2 plus 4, which is 2, minus 2, which is 0. And I can keep doing that and I just get some more data points on either side of that, 0.10. I can check that as well, or do this from the start. So I'm typing in negative 2x squared plus 4x minus 2. I'm going to look at my table around negative 2. So I can get some of these matching y values. And again, because of symmetry, it's going to be around this, so I'm just going to repeat the negative 2, the negative 8, the negative 18. So I've got 2, negative 2, 0, negative 2, 3, negative 8, and then negative 1, negative 8. The last one is in intercept form. So our x-intercepts, this is probably the quickest one to graph because 3 and negative 1 are the values that make those factors 0. So 3, 0 and negative 1, 0 are my x-intercepts. My axis of symmetry would be the average of those two, which is 1. That's right in the middle of those two. There's the axis of symmetry, which means my vertex is going to have 1 for the x-coordinate. So if I find f of 1, I'll get my y-coordinate. I'm going to plug 1 in place of both x values, and I will get a positive 4. Because negative 1 times negative 2 is 2, times 2 is 4. So I graph that. Now, that's 3 points, but I want to look at the table just to check my work and also make sure I have a nice accurate graph. So I'm going to type in that equation, negative 1 times x minus 3 times x plus 1. You absolutely need those parentheses in there. I'm going to look at my table. Well, let's just start with the vertex around 1. So I can see I've got the point 1, 4. So 2, 3. When x is 2, y is 3. That's right here. Due to symmetry then, 0, 3 will be another point because that's 1 unit to the left of the axis of symmetry. 3, 0 I had. 4, negative 5. So over 4, down 5. That points 3 to the right of the axis of symmetry, so I can put another point 3 to the left. And then 5, negative 12 would be right around here. So now I can connect all the dots and draw a nice, neat parabola with arrows at the end. Make sure it hits the vertex there. All right, feel free to watch the video over if you need things to be re-explained or gone through slower or multiple times.